October 15, 1997, NASA, in conjunction with the European Space Agency and the Italian Space Agency, launched the Cassini-Huygens probe, commonly referred to as Cassini, for its mission to the Lord of the Rings, Saturn. According to NASA, Cassini was a sophisticated robotic spacecraft sent to study Saturn and its complex system of rings and moons in unprecedented detail. Cassini carried a probe called Huygens to the Saturn system. The probe, which was built by the ESA, parachuted to the surface of Saturn's largest moon, Titan, in January 2005, the most distant landing to date in our solar system. Huygens returned spectacular images and other scientific results during a 2.5-hour descent through Titan's hazy atmosphere before coming to rest amid rounded cobbles of ice on a floodplain damp with liquid methane. Cassini completed its initial 4-year mission in June 2008 and earned 2 mission extensions that enabled the team to delve even deeper into Saturn's mysteries. Key discoveries during its 13 years at Saturn included a global ocean with strong indications of hydrothermal activity within Enceladus and liquid methane seas on Titan. The mission ended on September 15, 2017. Up until the Cassini mission, little was known about Titan. As of 2024, it's the furthest landing of our solar system and the only landing on a moon other than Earth's. The Huygens probe had revealed a side of our solar system that no one could have imagined. The moon had an environment, weather patterns, and a climate resembling Earth, leading many scientists to ponder what Saturn's largest moon could reveal about our own planet. After the Cassini mission, scientists were hell-bent on learning all they could about Titan. Why of all celestial bodies is Titan on the radar of researchers? Not only is it our morbid curiosity to discover the unknown, but Titan has a climate, structure, and environment that strongly resembles Earth, more so than any other planet in our solar system as far as we're aware. Data from Cassini-Huygens revealed Titan has lakes and seas of liquid methane and ethane replenished by rain from hydrocarbon clouds. The mission also provided evidence that Titan is hiding an internal liquid ocean beneath its surface, likely composed of water and ammonia. Before Cassini-Huygens began its focus study of Saturn's largest moon, we knew Titan as a hazy orange ball about the size of Mercury. Scientists had determined it had a nitrogen atmosphere, the only known world with a dense nitrogen atmosphere besides Earth. But what might lie beneath the smoggy clouds was still largely a mystery. The Huygens probe made the first direct measurements of Titan's lower atmosphere. Data returned by the probe included altitude profiles of the gaseous constituents, isotopic ratios, and trace gases, including organic compounds. Huygens also directly sampled aerosols in the atmosphere and confirmed that carbon and nitrogen are their major constituents. Huygens also measured radio signals during its descent that strongly suggested the presence of an ocean 35 to 50 miles below the moon's surface. The discovery of a global ocean of liquid water adds Titan to the handful of worlds in our solar system that could potentially contain habitable environments. Cassini followed up Huygens measurements from space, detecting other chemicals that include propylene, a chemical used to make household plastic, and poisonous hydrogen cyanide in Titan's atmosphere. The variety of chemicals observed indicates a rich and complex chemistry originating from methane and nitrogen and evolving into complex molecules, eventually forming the smog that surrounds the icy moon. It is believed that the methane and ethane rain falls from clouds in Titan's atmosphere, but the ultimate source of the methane is still unclear. Titan is the only other place in the solar system known to have an Earth-like cycle of liquids flowing across its surface as the planet cycles through its seasons. Each Titan season lasts about 7.5 Earth years. Cassini caught glimpses of the transition from fall to winter as Titan's South Pole, the first time anyone has seen the onset of a Titan winter, and watched as the summer came to the north. So in other words, Titan is the closest brother we have in the solar system as far as we know. The presence of organic compounds suggests that not only would it theoretically be possible for life to form, but some scientists speculate that Titan may have once had life on it. With all that being said, astronomers and scientists are dead set on learning more about Titan and what secrets of our solar system it may hold. That's why NASA has begun developing plans for a Dragonfly mission to Titan that is set to launch July of 2028 and land in 2034. The mission consists of a nuclear-powered flying drone roughly the size of an SUV, performing a series of hops along the moon's surface, collecting and analyzing substances believed to contain organic materials at pre-selected locations for at least 2.5 years after landing. While the Dragonfly mission passed a series of independent technical reviews early last year and was on track for its original launch date of 2027, NASA had postponed setting the final launch date due to uncertainty in how much money would be available for mission development this year and the next. The proposed 2025 budget request for NASA, released by the Biden administration in early March, allocates $2.7 billion for robotic planetary exploration that includes the Dragonfly mission, whose total life cycle costs will now be $3.3 billion according to NASA. The space agency said the mission's budget increased because of design iterations, supply chain issues due to the COVID-19 pandemic, and extra funds for a heavy-lift launch vehicle that would compensate for the delayed arrival at Titan by shortening the spacecraft's cruise phase. Over a decade before Dragonfly actually flies on Titan, several of the drone's components, including its control and navigation systems, have been tested on Earth. In July of 2022, mission engineers flew a drone identical to Dragonfly over California's Imperial Dunes, which resembled Titan's organic-rich dunes, and in wind tunnels at NASA's Langley Research Center in Virginia. NASA's official confirmation on Tuesday allows the mission to proceed with the final design stages. NASA is madly in love with Titan because, in a way, Titan is like the little or possibly older brother to Earth. Bear in mind that Titan isn't technically a planet, it's a moon, just like the one we see in the night sky. Yet because of its complex structure and climate, it could easily qualify as one. Just imagine if we had the ability to dig and terraform Titan. Based off the things that we find here on Earth, from fossils to archaeological digs, even the most absurd theories are equally plausible. Not to mention the possibility of obtaining more fuels and precious metals, replenishing Earth's supply. Part of the reason I love astronomy is the near infinite possibilities of things that could be out there. It's like if God made one big puzzle for us humans to put together to pass the time. At the end of the day, I'm looking forward to this mission, and the rest of us should be too. Until we meet again, thank you for watching, leave a like, and be sure to subscribe to the channel, and I'll see you in the next video.